As you know, this is where I will go over the content for each module that makes up each of our 9 units throughout the school year. Just a little side note here in general about learning. The more times that you are exposed to the same material in a variety of ways, the more likely you are to retain it. We'll talk more about this in person, but I highly recommend that after you take the notes for this section, you reread the chapter in your textbook. And that goes for all of the modules in all of the units. You might want to go back and just kind of look at the pictures, take any other notes that might help you to remember. Right? Visuals will maybe click something in your head that reminds you of something, that reminds you of something else, and that's how you make connections and remember the material in a real way. I promise you, if you do this, it will not be a wasted step. Go ahead now and pause for a moment, grab a pen, grab a seat, and don't forget to grab those notes for today's section called Unit 1, Module 3, Thinking Critically with Psychological Science. Our learning target today is to discuss the value of reliance on operational definitions and measurement in behavioral research. When we think about thinking critically with psychological science and what that really looks like, we're going to discuss the value of relying on those operational definitions, which are a huge part of it. But we're really going to take a look into the measurements of behavioral research in general as well. So stay with me here because we're going to be going over a lot of different terms. That said, this is going to be somewhat of a shorter set of notes in the scheme of things. So I'm going to go ahead and jump right in. Okay, so first up is a phenomenon known as misremembering, which is pretty much self-explanatory. It's when we don't remember an event or we don't remember the correct details of a particular event. I could go on for a whole hour here on memory alone and not even chip at the mountain of what we know about the human brain and memory. We'll be covering that a lot more in other units, but I will say here, misremembering can be defined as failing to remember an event or failing to remember the correct details of an event. Elizabeth Loftus conducted research on the misinformation effect, which we will discuss at length in a later unit, which will debunk our reliance on eyewitness testimony. Yep, all those shows you watch on crime, stay tuned for some real cool information on that. Hindsight bias is up next. By definition, this is when we look back on a learning event and we think to ourselves that we could have predicted that outcome. Some people call it, "I knew it all along" phenomenon. Just imagine your teacher quizzing you, and quizzing you, and quizzing you, and immediately after, each time you hear the answer, you didn't remember it at first, but you feel you did know it deep down inside, but once she said it is when you really knew it all along. This happens to me all the time when I'm doing the Wordle or the New York Times crossword puzzle, and I have to cheat and use clues and stuff like that. Or especially when I'm watching Jeopardy, I always believe that I would have gotten it right, but usually only after I've heard the answer. Oh my God, they said it, dang, oh, I knew it, I totally knew it. That little voice that you're hearing when this happens to you, that's your bias. Due to now having hindsight or looking back or behind to the immediate past and seeing what the answer was. Maybe you've heard of the expression, hindsight is 20/20. And if you've never heard it before, let me break it down for you. 20/20 is just a phrase that eye doctors use when testing our vision. It means that you can literally see that big eye chart with the E perfectly with 20 lines down, 20 feet away. Perfect vision is also known as 20/20 vision. But once we know that actual answer, we always have perfect vision when we're looking back in life, and that's the bias, right? A bias is an error in judgment, which is why we call it hindsight bias. As Homer would say, "I knew that Jeopardy question. They just said the answer too fast. Alrighty. So up next is a term called overconfidence. Overconfidence, which is big. We all tend to think we know more than we actually do. How long would you think that it would take to unscramble these 3 anagrams? I asked Lulu earlier, and she said 3 seconds. That's on average about actually what most people say. The truth of the matter is, it takes most people on average 3 minutes. By the way, water, entry, and the third one is barge. Okay, pseudoscience too is a big one. Pseudoscience at its real, pure definition is the opposite of thinking critically as a psychological science. So these are your popular beliefs that seem to be related to science, but really aren't. They include all kinds of things like ESP, mind readers, clairvoyance, astrology, magic, witchcraft, all that kind of stuff. They are not part of psychology, but people often confuse those terms with psychology, so be careful about that. Next up is confirmation bias. Confirmation bias is a little bit different from hindsight bias. In science, this is when you perform an experiment and you look for evidence in order to confirm your own beliefs or what you want to believe your research is going to prove, while you ignore all the other evidence that may disprove it. This could be in research, but it also happens in everyday conversations or disagreements or arguments that we have, or even just friendly discussions that you're having with a group of friends. And I want you to write this part down, it could be either intentional or unintentional. And subconsciously, you just don't even see the facts as they are, or hear it or experience it if it disproves your belief or the thing that you're trying to research. So, how do we overcome the pitfalls of things like overconfidence, hindsight bias, pseudoscience, confirmation bias, all of these things? Well, that's what these notes are all about. We must have what we call a scientific attitude, or mindset, you could say, which is step number 1. This attitude is composed of curiosity, wanting to explore. Also, though, having some skepticism and doubting and questioning things so you aren't just some gullible mush. And you need a little bit of humility too, right? Or being at least humble enough to accept the fact when you're wrong. And really having these characteristics changes everything for you as you become a more sophisticated thinker or critical thinker, so that you're not just this brainwashable figure on earth. And that's pretty much it. Critical thinkers do not blindly accept arguments and conclusions that we hear. When we hear something and we think, I'm feeling a bit skeptical about that, but I'm gonna listen, because I'm also intellectually curious enough to listen in the first place. But then you're sitting there and you're listening to this person, and you start becoming a little bit more skeptical. And then you start thinking, I feel like I should find out more about this person and who they're about and what they know to make sure if this is correct. Really, if there's one gift that you could give yourself today, my challenge to you would be to think this way with every single thing that you approach, especially social media and especially the news. I don't care how much you trust that blogger or that news anchor, or how wonderful you think they are. I do too. I love watching it. But I want you to challenge it, and I want you to find out if it is actually true or not when they say something. And does it examine all of those assumptions, discerns, hidden values? Does it evaluate evidence and assess conclusions? Here's an example. So, if you were giving, say, a statistic that says 1 in every 3 teenagers is predicted to be less intelligent than their older counterparts at their age, which is yours now. If you're watching this, you are a teenager because you're taking my AP psychology class. And this statistic is saying that you are said to be dumber than the people older than you are now when they were at your age. Would you just go and accept that? I'm hoping there's a little tinge of anger, like feeling inside of you saying, yo, what's up with that? That is total crap, I mean. But no, that's critical thinking. That's what it is. It's what I'm challenging you to have, a critical eye at every single piece of information that you take in. Scientific method is up next. I'm hoping that this is kind of a review for you if you've had living environment. So I'm going to go a little bit more quickly. How do we know when something is actually true? I want you to go even bigger and deeper than that now. We'll get kind of philosophical here. What is truth? How do you know if something is close to the truth? Well, psychologists, like all scientists, use that scientific method to kind of construct those theories, which in the science world, theories, although not truth, are as close to truth that scientists recognize we could ever be. So they use these theories to organize and summarize and simplify the observations so that other people can kind of digest and consume them. It's very, very systematic. Very systematic, so that in the end, something can be proved or disproved. It's not simply just common sense. No. We don't say that. Not common sense. No, not really. How do we know that? So a theory, being a really important part of the scientific method, is an explanation that integrates principles, organizing, predicts behaviors or events. It's highly researched, rigorously tested, right? And organized. Multiple studies under one umbrella of a bigger idea, right? Okay, so a theory is really just an idea that has multiple pieces of research and evidence to support it by multiple different parties or people involved. For example, let's take evolution, right? Evolution is a theory, and scientists believe that this is a theory as close to truth that we'll ever know about how humans came to be. Hypothesis is a big part of the scientific method as well. A hypothesis is a testable prediction often induced by a theory to enable us to accept, reject, or revise that theory. So when we have a statement of relationship between and among a couple of variables, so it's if this happens, then this happens too statement. Very important. If this, then that. Okay, let's move on. Research observation. This is huge. Simply just observing, it's the application of hypothesis, right? Research in general, though, is a systematic observation or manipulation of variables. And here in a few different sets of notes, we are going to talk about the very specifics of that, so that research in turn does support or disprove a theory, so that we have, and we'll have multiple pieces of research that either support or disprove that. Now, operational definition, if you get nothing from these notes other than this, you have reached success. An operational definition is a precise definition of a variable being observed in research, so that it is two things: highlights targeted, measurable, and manageable. Manageable simply meaning you can actually do it, right? No one ever said that they're going to do research surveys or experiment with 3 trillion people, right? No one ever says it because it would not be manageable. Really, hundreds of thousands of people is not even manageable. So it's not just manageable, but it also has to be measurable. So an operational definition is simply saying, if I want to measure, say, happiness or some other abstract concept, right? We know we can measure like the height or the weight of something. We know that we can do this with objects and things. But what about abstract thoughts or concepts like intelligence, happiness, alertness, aggression? How am I going to measure that? Because some might say, for example, well, you can measure happiness by, I don't know, how often people smile. Another person might say, well, I want to measure happiness by taking a survey where they tell us whether or not they're happy and what makes them happy. And there you have 2 different ways to measure the same variable, and that would be a botched research experiment. In that case, it would not hold up in the world of science. You have to say how you're measuring the variable so that it could then be replicable, so that other people could exactly replicate it. that research has to be exact so that you can come up with operational definitions. And I want you to do this on your paper. This kind of precise parameters are absolutely necessary in research because, again, it allows other scientists or researchers who are studying a similar topic to replicate the results. Alrighty, so go ahead and pause me and do that now. I want you to operationally define your variables. As I said earlier, there are some things that we can measure, like height or weight, or the time it takes people to do something, like a puzzle or a math or a word problem. But when it comes to measuring abstract concepts, like feelings and emotions, we must be very precise. So let me go ahead and do the first one for you as an exemplar for you to model. Okay, so happiness is up on top there, number 1. And we are going to operationally define happiness by recording the number of times that the subject smiles during a 10-minute time period while spending that time with someone they reported to feel love, admiration, and respect for. Now, another way of doing it, you could have said something like a 10-minute time period where they spend looking at photographs of people that they brought along with them, that you asked them of who they respected, admired, and loved. Something that brings them joy so that we can be sure that we are going to get moments of happiness within that 10-minute period. So go ahead and work on the next 4, and I'll see you all tomorrow on the other side. Night-night for now.